Okay, the bases are the same. We have a base of 2. We want to change it to exponential form, so we know we have a base of 2. We also were saying that the answer to a log is the exponent. The answer is 3. That's my exponent. We know that 2 cubed equals 8. We know this must be correct. So again, I'm going to suggest that you memorize this example and write it down whenever you're working with logarithms. Write this down so you can always remember how to switch back and forth. Because when we're solving equations, we often use exponential functions to help us solve a log function. And sometimes we use logarithms to help us solve an exponential function. Why don't you go ahead and see if you can change the next 2 into exponential form. So again, our bases are the same, and the answer to a log, 5, is the exponent. The bases are the same, and the answer to our log, -3, is the exponent. Try the next 2. The bases are the same, and the answer to the log C is the exponent. The bases are the same, and the answer to the log 7 is the exponent. The last 2 are important. They're almost the same. One has brackets, one doesn't. In the first one, log base 6 is applied to all of 3 plus x. In the second one, log base 6 is only applied to 3. In the last one, you need to isolate the log before you change it to exponential form. Let's look at log base 6 of in all 3 plus x equals 4. The bases are the same. The answer to the log is the exponent. We have 3 plus x here. In the last one, we need to isolate log base 6 of 3. Subtract x from both sides. Now we can change it to exponential form. The bases are the same. The answer to a log, 4 minus x, is the exponent, equals 3. I want you to really take a close look at those last 2 because that's a common place for errors, not paying attention to when there are brackets or when there are not brackets. Let's also take a quick look at solving a few exponential equations in this lecture. Now, remember what the question is that we're being asked here. When we're asked to evaluate log base 2 of 32, the question is 2 to what power equals 32? In question 2, log base 3 of 27 is asking 3 to what power equals 27? But let's look at some steps for evaluating these. I'm going to suggest that we say, let this equal x or y or m, it doesn't matter, and then change it to exponential form. All right, the bases are the same. So we have a base 2. The answer to a log is the exponent, and then we have 32. We were solving these last week. We just need to find a common base. X equals 5. Why don't you answer questions 2 and 3 and 4? So the bases were the same. The answer to a log was x, so that's our exponent. 3 to the power of x equals 27. When the bases are the same, we can ignore them. X equals 3. 2 more. 128 was 2 to the power of 7. X equals 7. But let's talk about these bigger numbers. I mean, they're a little bit difficult, but listen, you know, 3 squared is 9. Multiply it by 3 again, 27. Multiply it by 3 again, 81. Multiply it by 3 again, 243. It can't be that large. Exponential growth happens very quickly. You have paper, you have pencil, you can figure these out. We'll do more practice next time.